So far we've talked about what inverses are, what they look like, how to determine if the inverses are functions, verifying that two functions are inverses. Now let's actually do some finding of these inverses. First we'll start off graphically. So here I'm given a function and I want to sketch its inverse and then determine is the inverse a function. Well, one thing we have to remember from a couple of videos ago is that inverses reflect over the line y equals x. So what I'm going to do to start off is I'm actually going to draw that line in here. So I'm just going to make kind of a general sketch of what this looks like, something like this. This is my line y equals x. And what I'm going to do is I need to next switch my points or my coordinates. X's, well, that says x squared. I want x's and y's. So basically I'll take every single coordinate and I'm going to switch x and y's. I don't need to take every coordinate I see, but let's just take some of the most important ones. So here I have, here I have the point -1, 2. I'll just mark that, -1, 2. And that's going to reflect over to the point 2, comma, -1. See, I've switched the x and the y. So this point will be on the graph. Let's take a few more. I see that I have the point -3, 4. -3, comma, 4. So that's going to swap with 4, comma, -3. I also have the point, let's go in the other direction now, 1, 4. So I'll go 1, 4. Or sorry, I'll go 4, 1, excuse me. That point right there. And let's go one more out if I can. See, this is 3. It's not going to work out too well. I think that might be like 3, 10. So let's go out 10 and then, yeah, 3. Something like this. Roughly. All right, so now if I sketch this graph, it should look something like this. And we can kind of give it the eyeball test. We've gotten a few exact points. That's pretty good for me. But let's give the eyeball test. It looks like I've kind of reflected this over that line. And so, yeah, I think we've graphed the inverse pretty well here. So is this a function? Well, hopefully you could tell that already, knowing that this fails the horizontal line test. And this, being the inverse, will actually fail the vertical line test. So inverse is not a function. Whoops. Not a function. Okay, that's finding inverses graphically. We can do it with all kinds of pictures. We don't even know the equation. We just switched x's and y's. Let's talk about finding inverses algebraically now. So here is a function, -x squared plus 4. You can imagine what that looks like. You can think about what it might look like to reflect this thing. But let's talk about just the algebra. First thing I'm going to want to do is I'm going to want to write the equation with y's and x's. And this equation, we like y's and x's because we think about x as being the input, y as being the output. Here's some rule where I stick in some x value and it spits out a y value. Next thing I'm going to want to do is let's take that equation that I have and let's actually switch the x's and the y's. I'm going to swap them. Wherever I see an x, I write a y. Wherever I see a y, I write an x. And that is because an inverse function switches your domain and range, switches your input and your output, switches your x and your y. So we can just start by rewriting the equation with x's and y's. And actually, here's a little side note. I could graph this, and I encourage you to try graphing this, just as it's written, in Desmos. Pause the video if you need to, pop open a new tab, and just write this, x equals -y squared plus 4. You'll get a graph, and it is the inverse of this graph. So it's kind of cool. Check it out. Can't do that with the TIs, I don't think. All right, next thing we'd want to do is we want to now solve for the new y. Really what we've done when we've swapped x and y is we've switched our new input for our new output. And now we just like to have functions written when they're equal to y, so that's what we're going to do here. We're going to go through all the algebra steps, undoing this thing so we get y by itself. So I move this 4 over, I got to bring that negative to the other side, square root it all, and one thing I have to keep in mind is the plus or minus. Since I'm taking the square root of something being squared, I do need to include the plus or minus here. And then the last thing we like to do is we like to write this with inverse function notation. So I'm really rewriting the same thing I just got, but I'm specifying that this is an inverse function, f inverse of x. And the reason why I write it like that is because that just points me back to where I originally started, saying that yes, this is indeed the inverse of my function that we call f. So here's another example, a little bit trickier, but we can handle this. Let's follow the same steps as we did before. This is a rational function. I want to find h inverse of x. So the first thing let's do is write out things with y's and x's. Y equals 2x plus 3 over x minus 1. Then let's switch our x's and y's. So x will equal 2y plus 3 over y minus 1. And now I need to solve for x. So what I'm thinking is I'm going to want to multiply both sides by y minus 1. Y minus 1. And that's going to give me, let's go with another color here. That's going to give me x times the quantity y minus 1 equals 2y plus 3, since these factors will reduce to 1 over here. Next, let's distribute that x. It's giving me xy minus x equals 2y plus 3. And now I'm kind of pretending like this is literal equations. My goal is to solve for the y. I see two of them. I see a y here, and I see a y here. So let's get them all onto one side. Let's move this 2y over, and then let's actually add this x over. We'll kind of do two things at once here. So this is going to give me xy minus 2y equals x plus 3. I just move some stuff to other sides. Next thing I want to do is I want to group these y's together. So I would like to have just one y by itself, not two of them. So I can factor out a y at this point. So I get x minus 2 equals x plus 3. Now let's divide everything by x minus 2. Divide this by x minus 2. This will reduce, and I get y equals x plus 3 over x minus 2. Final thing I'm going to want to do here is rewrite this in inverse function notation. So this is h of x, so let's call this h inverse of x equals x plus 3 over x minus 2. And I'd highly encourage you to use your graphing calculator or use Desmos.com to actually graph both of these functions and just verify that it looks visually like it makes sense, like it's reflecting over that line y equals x. All right, here's a you-try example. Give this one a shot, pause the video, see if you can't work it out. And here's my solution for this guy here, f inverse of x. This is not f inverse of x, this is k inverse of x. So, my mistake. Here's another you try, another rational function. Follow the steps and look for the inverse function. All right, you didn't see an f, that is an r. R inverse of x is equal to all of this. Things got a little tricky at the end. I kind of pulled out a -1, so if you're not sure why this is now 3 plus x, that minus sign is on the outside of this thing. So hopefully this made some sense. We have talked about graphs, we've talked about equations, we've talked about what inverses are, and hopefully this is ringing some bells and you're ready to dive into some practice in class.